we're going to take notes on compound inequalities and how to solve them. So compound inequalities are two inequalities joined together by and or. Our first type is an or, which is a disjunction. Or inequalities or disjunctions have a tendency to graph apart, or you could say opposite ways, out. So if we were to graph x is less than or equal to -2, we're going to put a closed circle at -2, and we want to shade less than that, so we're shading towards the left. X is greater than 3, so an open circle at 3, and we're shading greater than to the right. So a disjunction uses the word or, and we shade apart, opposite directions, we shade out, however you want to think about it. Here's how we solve. In lesson 3.1 and 3.2, we were solving normal inequalities. Okay, so that's exactly what we're going to do here. I drew a squiggly line down the middle because these are two totally separate problems that I'm going to solve separately. So if I look at the first one, it says x minus 4 is less than -7. And if I want to keep my two sides separate and organized, I can draw my line down. And we're trying to get this x all by itself, remember? So we need to get rid of or move this -4 to the opposite side. So the opposite of subtraction or negative is addition or positive. So we're going to write add 4, whatever we do to one side, we have to do to the other. And we're actually done. X, bring down your symbol. -7 plus 4 gives us -3, and that's the first part of this problem. The second inequality says 2x is greater than or equal to 12, and we're trying to get x all by itself. 2 and x are smushed together, which means they're being multiplied. So the opposite is divide. Divide. Those cancel. Bring down your x. Bring down your symbol. 12 divided by 2 is 6. And we're going to put the word or back in the middle. And this is my final answer here. So then we can graph this answer. So x is less than -3, so we're going to put an open circle at -3. Less than shades to the left. X is greater than or equal, so close your circle, to 6. Greater than goes to the right. And we're done with that question. Okay. So we have two inequalities. We're going to solve them both separately. Solve them both separately. Okay. So if I look at this first one, I see it says -3x. So -3 and x are being multiplied. The opposite here is to divide by -3. Divide by -3. And your brain should be going ding, ding, ding. Alert, your light bulb should be flashing because we divided by a negative number, which means we need to switch our symbol, our sign. So put our inequality sign the other direction. -9 divided by -3 gives us a +3. All right, next I see 5 plus x. So I want to get rid of that 5. So the opposite is to subtract 5. Subtract 5. We get x is less than 1. Notice how I always box in or circle my final answer. So x is greater than or equal to 3, so close circle at 3. Greater than, we shade to the right. X is less than 1, so an open circle at 1. Less than, we shade to the left. So again, this is a disjunction. We're shading opposite ways. We're disconnected, and we use the word or in between. All right, question 3, same thing. We're going to solve these separately. So we want our 2x by itself. So let's move this positive 9, and the opposite is to subtract. Bring down your 2x and your sign. 17 minus 9 gives us 8. Divide both sides by 2. X is greater than 4. That's the first part. The second part, we want to get 5x by itself. So we want to move this 10 to the other side. So subtract 10. Bring down your 5x and your symbol. 10 minus 10 is 0. Divide both sides by 5. And we get x is less than, we have 0 cookies for 5 people, so they get 0 cookies. So this would be my final answer. X is greater than 4, open circle, greater shades to the right, or x is less than 0, so an open circle at 0, and we shade to the left. Because we've been solving for x all year, what I would like you to do is to answer questions 4 and 5. 4 and 5. So keep these questions separate. Okay, you want to solve for x in both problems, so draw your lines down to keep yourself organized. Here, remember, we need to distribute first. Okay. Then when you're done solving, make sure you graph your answers. You can do it. All right, let's look at and inequalities. So this is a conjunction. And inequalities have a tendency to graph together or in the middle or to connect. So if we were to graph this one, it says x is greater than or equal to -6. So we're going to put a closed circle at -6, greater than shades to the right. And x also has to be less than or equal to 1, so less than, we shade to the left. So notice we're shading in the middle to connect our two circles or our 2 points. We shade together. Connect, conjunction. But when we were looking in our book, we noticed that they drop the word and quite often, because we can write this as a big connected problem, a big compound inequality. So we're going to use the same example above. But we're going to write this as one condensed inequality, because x falls between these two numbers, between these two endpoints. So our endpoint furthest to the left, or our minimum or our low number, is -6. So I'm going to write that first. My maximum, my highest number, or my endpoint furthest to the right is 1. And I need all x values in between those two. Okay, and notice here that x is greater than or equal to -6. So x still needs to be greater than or equal to -6. Focus on your mouth, Pac-Man mouth. And then x is less than or equal to -1. Okay, notice these inequality signs or symbols face the same direction. All right, let's focus on solving. So in order to solve these, I am going to draw 2 lines down because I have 2 inequality symbols. And if I'm looking, I notice that my x is right here in the middle. So I'm going to work from the middle or from the inside out. So if I look at the middle, what's next to the x? It says +4. So I need to cancel out or get rid of that +4. So the opposite is to subtract 4, and that cancels. But whatever I do to the middle or to the center, I need to do to my 2 outsides. To the left, so subtract 4, and over here on the right, subtract 4. 2 minus 4 gives us -2. Bring down my symbol, bring down my x, bring down my other symbol, and 9 minus 4 is 5. And x is all alone in the middle, so this right here would be my final answer. So if we were to graph this, we would put a closed circle at -2 because we have the or equal to line. -2 is included. An open circle at 5, and we're going to shade in the middle to connect. Conjunction is connected. And we're done. Question 7. I'm going to draw my 2 lines down to keep me organized. And notice I have this 7x in the middle that I want to solve for or to isolate first. So again, we're going to work inside out from the center to the 2 outsides. So how do we get 7x alone? Or how do we move this -13? Add 13. Whatever I do here, I have to do to all 3 parts, the left, the middle, and the right. So over here, we're going to add 13 as well on the left, and on the right, we're going to add 13 as well. -27 plus 13. We get -14. Bring down my symbol, 7x, symbol, and 8 plus 13. We get 21. Is x alone yet? No, it's not. It has a 7 in front of it. So 7 and x are being multiplied. So the opposite of multiply is divide by 7. Now I have to do it to my 2 other sides. So over here on the left, divide by 7. On the right, divide by 7. -14 divided by 7. -2. Bring down your sign. X. Bring down your sign. 21 divided by 7 is 3. And box in or circle your final answer. So we have an open circle at -2 and another open circle at 3, and we need all x values in between those 2 numbers, so we're going to shade in the middle to connect them. What I would like you to do is pause the video and please try question 8 on your own. It's very similar to question 7. You can do it. So I need to get 3x by itself. So I'm going to add 4 in the middle, and on the left, and on the right. Negative 16 plus 4 is negative 12. 2 plus 4 is 6. Now we need x alone, so we're going to divide by 3. Divide by 3. Divide by 3. So whatever we do to one part, we have to do to all 3 parts. This would be our final answer. So I have a closed circle at negative 4, a closed circle at positive 2. I need all x values in between those, greater than negative 4 and less than 2, so we shade in the middle to connect those. Question 9. We have a fraction here. Which is okay. We've dealt with fractions a little bit this year. We're going to draw our lines down. We want 2/3 x by itself. So let's get rid of this plus 1. What's the opposite? Subtract 1, subtract 1, subtract 1. So negative 2. 5 minus 1 is 4. Now, if you remember, back when we were doing fractions, in order to get rid of them, we multiplied by the reciprocal, which multiplying by the reciprocal means to flip the fraction. So the numerator and the denominator switch. So I'm going to multiply by 3 over 2. 3 over 2, and I'm going to multiply by 3 over 2 in here as well so that these just cancel each other out. We can use our calculator and do 4 times 3 over 2, or we could do it together in our heads. So what's 4 times 3? 4 times 3 is 12. What's 12 divided by 2? We get 6. Good job. Same thing over here. We could type in negative 2 times 3 divided by 2 into our calculator. So you could pause and do that. Or, what is negative 2 times 3? Negative 6. What's negative 6 divided by 2? We get negative 3. Good job. So we have an open circle at negative 3, closed circle at 6, because this is one big condensed problem. It's a conjunction, so we shade to connect. In the middle. X is in the middle between negative 3 and 6. Draw my lines down. If I'm working inside out, I notice I have parentheses. So 2 times x, 2 times negative 6. Distribute. I want you to pause this video and finish question 10, and don't forget to graph it. 2 times x is 2x. 2 times negative 6 is negative 12. Bring down your sign and 4, sign and negative 2. We want the 2x alone in the middle, so we're going to add 12. Whatever we do to one part, we have to do to all 3. So negative 2 plus 12 gives us positive 10. Sine 2x. Sine 4 plus 12 is 16. We need to get rid of this 2 in the middle. 2 and x are being multiplied, so the opposite is to divide by 2. 10 divided by 2. 16 divided by 2. So we have an open circle at 5, closed circle at 8, and we need all x values in between these in the middle, so we're going to shade to connect them. And we're done. Good job.